Hi and welcome. I'm Dvogonen and this is the release video for Cyclops version 1.2. Cyclops is a special firmware for the Quanum Cyclops. What Cyclops brings to the table is support for an external screen for channel information and support for selecting channels. And I'll give you a super brief presentation of the features, and then I'll take the visor apart and show you how I made the modifications to it. Okay, so here we go. Let's start by connecting the power. And the visor boots up. You can speed it up a bit like pressing the button. Like so. It automatically saves the last used channel, so you don't have to think about that. And at the moment there is nothing transmitting on 5880, and you have a very low RSSI value of 182 here. And 5880 is Fat Shark 8, which can also be seen down there. Okay, I'll take this little quad here and connect it, so you'll have to excuse some beeping. Like so. And the RSSI went up. Let's see if that was actually the... Do I have a picture? No, just static. But it's somewhere near, so let's search for it. Just like you can do with the basic firmware. And we got an image here. Okay, so we're on the right band. And basically that's what you can do. You can, by long pressing this, get the original functionality. It will take the best signal available, but there are some other stuff. You can also press it even longer, like 3 seconds, and then you've got the band scanner mode. It started on that channel it was on, and as you can see, it's the only one available on the spectrum. So what you do is you wait until you see the cursor close to the correct frequency, and then you press the button like this, and it will scan and see which was the best frequency possible. And we've got picture again. Okay, what you can also do is that you can step upwards and downwards, like so. One short press goes to the next available channel, 5880, and backwards with a double press like that. So I'll turn off this hideous beeping. And there went the RSSI value down to 183. I'll take this visor apart and show you how I modified it. And I'm sure you can figure out how to do it in the other direction, so to speak. I'll go and get myself a screwdriver here so we can open it up. Battery is disconnected and I've got the screwdriver. So let's unscrew the antenna. And that's all there is to it. It's now ready for disassembly. So okay. And the first thing to do is take out the Fresnel lens, like so. Put it aside. Don't touch it, it's very hard to clean dirty Fresnel lenses. And this is the guts of the visor. This board here is both the receiver board and the power distribution board for the display, and they made it very easy to remove it because it's on a kind of a sled. Pull it out, but I've got this extra wires that I've attached, and that one. These will not be in when you pull it out for the first time. Okay, so before you do anything, you should remove the battery cable on this side. And this is the cable going off to the display with This is power to the display, and there is one ground wire, and I don't know why there are two other ones, if it's if you actually have two video wires or not. I don't know. Okay, so this is the combined board. On this side you can see the receiver module, that's the one in a tin can here, and here you have a small card. This part here is a buck converter that converts the battery power that comes in this contact to 5 volts. Okay, on the other side here you see a regulator that regulates the 5 volts down to 3.3 volts, which is what the processor over here uses and the receiver uses. Okay, and the only additions I made to this is that I've soldered in this part here. This is a so-called ICSP header, in-circuit serial programmer header. Okay, and to this you can connect any standard Atmel 6 pins programmer. What I've done here is to add another small contact that makes it easy for me to remove and insert the card. Okay, so these 3 solder irons under these pins can be used right off. So it was very easy to attach this. And then I've used 5 volts. You can see it here. So I've just taken a wire from 5 volts there. I think that you can use 3.3 volts. It's over here. So the displays supposedly work on 3.3 volts. Of course, you don't have to solder anything. If you don't need the display, you don't need this part, and you can get away without actually soldering this. If you just have a header like this, you can put it in the programmer and just press it into the holes and hold it down when you're programming, and that's it. So you've put together your visor, or decided to program the board outside of the visor. In any case, now it's time to take a look at what you need to program it. You need one of these. This is a so-called ICSP programmer, and this particular one is a USB ASP. There are many different kinds. This is the absolutely cheapest one. It's just $2.50 or something like that. Okay, these typically come with a 10-pole connector, and hopefully with one of these. This is a selector for voltage level going out. Some USB ASPs don't have a voltage going out. You can't use those. Some only have 5 volts out. You can't use those either. You need one of these, which you can set a jumper to select between 5 volts, or in this case 3.3 volts, which is what we need. You also need the standard ribbon cable, 10 poles, and at the other end we need 6 poles, because that's the programmer we attach to the board. And either you get a special cable like this one, or a small adapter. That's basically as a board that goes at the end of a 10 pole to 10 pole cable and has 6 poles at the other way. There are plenty of those available on eBay too. Okay, and I'm connecting these and taking great care. The VCC needs to be connected to VCC on this board. Okay, all the other mix-ups you can do won't destroy anything, but mixing that up will destroy the board instantaneously. I'll connect it to my computer like that, and I've got my driver installed, which you haven't, so things will start working. The problem for you though is that you haven't installed the driver yet. And that's kind of problematic, because installing the driver for a USB ASP is very problematic, because it isn't signed. So you will have to jump through all kinds of hoops to install it. I suggest that you Google for installed unsigned driver Windows 10. There are plenty of people explaining how to do this. And you can also Google for install USB ASP Windows 10. It's possible, but it takes quite a lot of effort to do it. So don't get upset when it doesn't work at first. Anyways, when you've been able to install the driver, you will be able to see it in the device driver as a USB unit, like this one, a USB ASP unit. The next thing you need is a programmer program, and the one you're going to use, if you want to do it the easy way, is called AVR DoDes. AVR DoDes. Find it and install it, and then we'll run it. Select the programmer to start with. We'll take the USB ASP down here in the list from Fischl.de. That's the one. And it's not on a port, it's on USB, like so. And now hopefully things should work when we press detect over here. And no, things didn't work. So this is the second try. I've changed USB port, and yeah, it worked. It detected an Atmega 328P, and that's exactly the processor that's in the visor. Okay, so we've got a working connection. This might take you a couple of hours to get to. So the next thing we need is a file to flash, and you'll find that by pulling up the web browser. And I've already started it on the project page on GitHub, github.com, Quanum Cyclops Plus. And there will be a link to this in the description, because on this page you've got downloadable here, cyclops+.x. This is the binary file, and you've also got a written explanation of exactly what I've been talking about in this video here. So we'll just download this one. So we'll select it here in the flash box, because what we're doing is called flashing when we talk microcontrollers. And it's available on the desktop, like so. And let's check. We want to write, and let's start it. And over here, do this is writing, and when it's written it will verify that the file is correct. And that's it. That's all there is to it. If you want to build the code yourself, you will download the Arduino build environment and install it. It's very easy. And then you'll download the code and start the project. It's called something.ino. All Arduino's projects are called ino. And it will start up in a window like this. And basically the project is contained in two files. One called Cyclops Plus CPP and one called Cyclops Plus Age. And you can see and change all the code here. And now we can actually upload it from here. We don't need the AVR DoDes to do this. We do need the AVR Dude program, but it's part of Arduino as well as AVR DoDes. So under Sketch we've got upload with a programmer, I guess it's called in English. And before you do that though, you need to set the correct board. And the board we're using is the Arduino Pro or Pro Mini. This is hardware-wise very close to what we've got inside the visor. And the processor needs to be an Atmega 328 3.3 volts. Otherwise the clocks will go out of sync. So that's the settings we need to do. And then we could use upload with programmer like that. And it goes back and compiles yet again. And now it's uploading. These messages here are completely normal. It says AVR dude cannot set S clock period. Please check for USB ASP firmware update. You shouldn't do that. This is completely normal. It says so every time. Okay, so we're done. We've uploaded the binary for those who are not interested in building, and we've built all the code and uploaded from Arduino for those who are interested to do so. And just to prove that things work, I'll turn on the power. Never turn on the power before you have removed the power from the programmer, of course. That's a given. So, let's see. Hopefully things work. Yep, booted, just like before. Starts just like before. And goes to 5645. Okay, that's all for today. Hopefully you'll found this little project entertaining and interesting.